Can't believe, Logan, and she said teachers are annoying.
She said that.
No, you. Oh, don't, now you're blaming her, Logan. I just want to make. You know what? I'm going to send this recording to your parents now. Today we're looking at a whole bunch of definitions. Polynomials. That's just fancy algebra. We're going to talk more about what exactly the polynomial means later. First of all, algebra is the branch of math that studies unknown values, and it's using letters and symbols. Okay, so you use this stuff forever and ever in math, all the time. Even if you go into different math like calculus, you're using letters. So you need to be really strong in it, have a good foundation of different things, okay, that we do with the letters. Okay. Was actually first looked at and studied in the Middle East. Okay, so you can, the original text was Arabic? How would you say that? Arabic, okay. And so then it's been translated into English. So that's like back in the dark ages there. So with algebra, we talk about terms. Okay, so terms are numbers, symbols, and letters, or a combination of them. And there's some examples. So the number 9 is a term. 9x is a term, and remember, a number in front of a letter is a multiplication. Negative 3y is a term. Sometimes you have to include the negative sign. xy is a term. Okay? There's no number in front. We don't write the number 1 in front, the coefficient of 1. wx squared is a term, and even one letter by itself, like u is a term. So those are all examples. Now we separate terms by plus or a minus sign. Okay. So for example, we have 3x squared minus 2x. So that's an expression. It's a binomial. We'll talk about what a binomial is later. But there are two terms there. I'm going to use my green pen and separate them. We have 3x squared term and a negative 2x term. Okay. So the terms are 3x squared and negative 2x. Notice how your subtraction is also like a negative sign. So you got to kind of start thinking about your subtractions as negatives and your additions as positives, because we use that a lot. Okay. Any questions about what a term is? You know, as you work with this definition in your homework, it will sink in and make sure that it's solidified properly. So then we talk about a monomial. Okay, so the root or prefix, I think it's a prefix, is mono. Mono stands for one, like a monorail has one rail, just like in Seattle. So mono is one term, and basically there's no adding or subtracting in there. There's multiplication, because letters are beside letters, but there's no adding or subtracting. Okay? That adding and subtracting you see is pointing below, so just don't write it down yet. Okay, so then the next one is going to be binomial. Binomial has the prefix bi, just like your bicycle has two wheels. Okay, and so binomial has two terms. An example would be 3 plus x. There's an adding or subtracting that separates them. Okay, so adding or subtracting is what separates your terms. Now we have another expression here. We have 2x minus 4x. Sorry, 2x squared rather, minus 4x. And the terms are 2x squared and negative 4. So again, I'm going to use my green pen. Okay, and that's where the terms are separated. So that negative sign or subtraction sign belongs with the 4. And that's why we have a negative 4x. Well, it's positive 2, so we can write it as plus 2. Just overemphasizing it's positive and not negative. Okay? You don't need to write that. Okay? Any questions about that? So again, the negative sign doesn't belong with the 2x squared. I just overemphasized that. Okay? We wouldn't normally write this but you can. I just did that to emphasize it's not negative. Okay. So after binomial, what do you think you're going to have? Good. Just like a tricycle has 3 wheels, trinomial is 3 terms. Okay. The example will be x plus 4y negative 2. The terms are separated with green pen, so you can clearly see. Again, it's important to see that minus 2 is a negative 2. Okay, the sign in front stays with the term. Okay, so polynomial, what does that mean? Well, the word poly stands for many. So technically it's 4 or more. If you have less than 4, we tend to use the prefix monomial, binomial, trinomial. Now sometimes you can use, and I do see it, polynomial kind of covers everything, but it's specific for 4 or more. And if it's 3 or less, you should use the specific name. Okay. Then, coefficients. We've looked at those a little bit. We're going to look at them again. Those are the numbers in front of the terms. So for example, if we have here negative 2x, the coefficient also involves the sign. So the sign is negative, so our coefficient is negative 2x. We do not write the one coefficient. Okay, so for example, x, the coefficient here is 1. Plus 1. Versus negative x, where it is a negative 1. Okay, so we don't write those ones. Often I see it, and I don't really mark it wrong anymore. Okay, but try not to. Otherwise, it's like saying things twice, because you don't need to write a 1. I know it's a 1. You already wrote the letter. Okay.
But wouldn't the negative 2 also be a term?
No, it's not, because there's no adding or subtracting in between them. It's multiplication. Okay. If I had x minus 2, x squared minus 2x, now I have 2 terms separated by that sign. Okay. All right. Constants. So constants are constant. Their value does not change. So the constant has no letter. It's always the same value. It's just the number by itself. So for example, if we have 3x minus 4, the x value can change. We can say x equals 3, or we can say x equals 10. But the constant doesn't change. The value of negative 4 stays the same. Okay. So x can change, meaning 3x can change. But negative 4, the value will never change at all. So what does your constant stay? Constant stays constant. Okay. Degrees. All right, so degrees, there's 2 things you got to look at: the degree of the term, the degree of the polynomial. So for the terms, we can do a little chart. Okay, so we have degree of the terms and degree of the polynomial. Basically, you want to add the exponents on the letters. Here. So on our little chart, we have the expression 3x. 3x is a degree 1. And that's because on our x, we have the exponent 1. So you're going to see it not written there, but you have to always know that's a degree 1 exponent.
So the degree is
The 1 exponent. Exactly. So if there's 1 letter, it's just 1. Okay? Or if here we have 2 letters, x and y. And then I added 1 plus 1, so that's going to be a complete degree 2. And the reason why is because our hidden 1 exponent gets added together. Okay, so write that down as the example.
Doesn't 3 have an exponent?
No, it's not a letter though, so we don't need to look at it at all for degree. Okay, the coefficients are not involved, just the letters, variables. Okay. Okay. So then, looking ahead, we have 4x squared y. Again, you only look on the letters, x and y, add up the exponents. So we should have 2 plus 1 equals 3. Okay. Any questions about that? Then for the polynomial, you just pick the highest term. That's it. You pick the highest term. So please write down 3x squared plus 2x minus 1. Then I want you to separate them, please. Separate the terms. Just like I did with my green line, separate the terms. So we have one term that is 3x squared, one that is plus 2x, and one that is minus 1. What's the degree of the first term? 2. Degree of the second term? Degree of the last term? 0. Technically, there's an x0 there, although we don't really test that, okay? So technically, there is an x0, but that's our constant. It has a degree of 0. So which one's the highest? 2. Very easy then. This is a second degree polynomial. So we don't do any more adding after we look at the terms. After we look at the terms, we pick the highest number. We pick the highest degree. Okay. All right. So we're going to do that again. All right. Write down the term. Okay, so you should have them separated right here. What's the degree? 3. Okay, don't forget the 1 on the y. What's the degree? 2. What's the degree? What's the degree of the whole thing?
Degree polynomial.
Yeah, 5th degree or degree 5, whatever you want to say. Okay, we're not too particular about that. Okay. Any questions about how to find the degrees? Okay. Okay, a couple little side points. Number 1, never write the exponent 1 or the coefficient 1. We know those ones are there just because we see the letter or the variable. Okay, so we never write that. Another kind of golden rule, you should try and write the terms in alphabetical order. Are these the same?
No.
Really? Really? No? Yes? Not sure, are you? Well, look, yes. Look at the letter in the exponent. X cubed, that's the same. Y and y, that's the same. So those are both x cubed y terms. The only difference is this person shouldn't have written it yx, they should have written it x cubed y, right? Because x is in front of y. But you could add them together because they are the same. We're going to talk more about that next class. Right? Another thing is, then for polynomials, you want to write them either in ascending order or descending order. In descending order, you should highlight because that's the more common way you're going to see them for this unit and for next year and stuff. I mean, I'll quiz you and I'll say, put it in ascending order. Okay, but descending order is more where you should write it. Okay, and it's more common to see it that way. But of course, as honor students, you're ready for everything. So the way I've written it, here I have degree 0, degree 1, degree 2. So it's going up. Whereas the second one, descending order, is degree 2, degree 1, degree 0. Okay, so 0, 1, 2, or 2, 1, 0. So that's why it's in ascending or descending. All in terms of the degree. Okay. And really, that's kind of the only reason why we look at degrees. You don't really do anything else with it, to be honest with you. Which usually I'm not, because I always like to lie to you. Oh, I better delete that one.